Alright, so we're going to start with Unit 2.1, and this is Day 1, and we're going to talk about quadratic functions. We're going to be talking about quadratic functions over the next few days, and then over the next few videos. And the idea is that we're going to culminate this with an idea of how we can use quadratics, we can identify quadratics, and know the different special characteristics that each quadratic has. So as we move into our objective is to simply just graph quadratics using a table of values, and then graph finding the vertex and what we call our axis of symmetry. So we're going to be looking at some special characteristics that maybe we haven't known before or haven't seen before. So the first thing that we're going to look at is what we call a quadratic function. And so there are a couple particular things that we look at when we look at a quadratic function. First of all, we have what we call this parent function. And when we kind of reference a parent function, it's the most basic. So it's the most simplest form of that particular function. And in this case, that particular function is x to the second. So the whole idea of a quadratic function is it's a function that has a highest degree of 2. So when we look at these things, if we see an x to the second and there's nothing higher than that, then that's what we're going to refer to as a quadratic function. Now it could be one term, it could be two terms, it could be three terms. It doesn't matter as long as the highest degree is 2. It's something that we're going to consider quadratic. Now most of the things that we're going to look at, one thing that we kind of need to mention is we're only going to be working with one variable. So if we see more than one variable, so if it's like xy, that's technically a degree 2, but that's not going to be a quadratic. That's going to be something completely different. So if you look at this, the function based in x is going to equal x squared. So another way that we can write this would be y equals x squared. So when I talk about one variable, y doesn't necessarily count because that's what it's going to equal. So just dealing with one variable, which is going to be x most of the time when we're graphing. So with a quadratic function, there are three different forms that we can use. We can use what we call standard form, what we call vertex form, and what we call factored form. So the first one that we're going to look at is our standard form that we know most of everything about. And we know this. And so the first one that we're going to look at is standard form, which we know, which would be ax squared. Let me start over here. It'd be y equals ax squared plus bx plus c. And we've kind of already been using standard form in most of the things that we're doing, but obviously you know that standard form is everything ordered from highest degree to lowest degree. The second thing that we're going to work with is something that we call vertex form. Now vertex form is y equals a, in parentheses, x minus h squared plus k. Now this is something that we're going to get into later, but at least look at these things. Each one of these values means something a little bit different, but notice since we have a degree 2 right here, that's what makes this a quadratic. And finally, we have our factored form, which would be y equals x minus a times x minus b. And so those are the three forms that we're going to reference throughout this entire unit. So just make sure that you're aware of these different things and you're writing these things down, that we have standard form, vertex form, and factored form. Now the first thing that we're going to do is we're going to look at what a quadratic function actually looks like. So most of us know what a quadratic function looks like, but if we take this equation here, f of x equals 2x squared minus 8x plus 8. This gives us a particular variety of a quadratic that we can use, and that we can kind of tailor to our own kind of view here. So if I actually go ahead and graph this function here, this is what this function would look like. It would look something along this line. Now obviously my drawing is pretty poor since I'm using this on an iPad, but the idea is that we get this kind of unique shape. Now if you notice, there are 2 points of interest that I put on here. I put a point of interest here and I put in a point of interest here. Now the reason that I put those on there is I'm going to discuss those in a little bit. But the shape that we call a quadratic is what we call a parabola. So whenever you see a quadratic, we always want to refer to it as being a parabola. So when we look at this parabola, it's another name for this would be a U-shape. Now if you look at the shape here, I didn't make this a V like this. It kind of swooped at the end. But if you notice, they're both kind of going outward towards each other. So it's not just a straight up U where you have just a bottom curve, but the idea is that we have something in that general shape of a U. without the tail. But the idea is that we have it both going in the same direction. Some of the things that we know is one of the things that we've learned before is that this is even. And so if you look at the end behavior is going up, which means that our coefficient is positive, which we see a positive 2 there. And they're both doing the same thing, and that tells us that this is an even polynomial. So we can kind of still look at these things that we've done before, but just know that a quadratic is also referred to as a parabola. Alright, so if we look in depth of some of these characteristics of a quadratic, so if you see I have that same thing just kind of reproduced here at the side. And so there are 4 different things that we can kind of talk about. One of them is what we call an axis of symmetry. One of them is a vertex, one of them is an x-intercept, and one of them is a y-intercept. So I'm going to go ahead and give you those definitions now. Alright, so if I look at these definitions, the first one that we have is what we call a line of symmetry, or an axis of symmetry. The axis of symmetry is, it's actually a vertical line. So it's a vertical line that divides the parabola into 2 parts that are mirror images. And basically what that's going to do is it's going to cut right down the middle. And so if I was to take a particular line and I was to kind of imagine this line here, it's going to cut all the way through the middle. Now pardon my not very straight line there, but the idea is that this is kind of a dotted line that goes right through the middle of the parabola. And so if I kind of look at what that's doing there, the parabola is going to get cut in half, where we're going to have one side on this side, and then we're going to have another side here, and they're going to be identical to each other. So if you wanted, you could take this line over here and plop it over, and it would just fold over on top of itself. Notice that I put 2 points of reference here. So these 2 points, if you look at it, are the same distance away from this line of symmetry. So this is 2 points, or 2 units, and this is 2 units away. So the idea of an axis of symmetry is that it's going to cut it in half so that you can have equal sides on both sides of the parabola. Now the vertex is a point at which the parabola intersects the axis of symmetry. And it's actually going to be right down here. So it's kind of going to be at the base of the parabola. Now we've kind of talked about 2 words here. And so a vertex is also known as either the minimum or the maximum. And we've kind of looked at what a maximum is. We've kind of looked at what a minimum is. But the idea is that vertex is the minimum or it's the maximum. And one of the things is that axis of symmetry goes through the vertex. So we can kind of look at and find the vertex, and we can find the axis of symmetry kind of at the same time. You find the vertex, put a point there, and then the axis of symmetry is a vertical line that goes right through that point. The x-intercept, in some cases it's a point or multiple points. Usually with an x-intercept it's only going to be 2 or less. And so it's going to be at the point where it crosses the x-axis. So here, this is my vertex. It's also my minimum. And it's also my x-intercept. And so there's just a certain situation where we can identify each one of those points and have multiple different names for a particular value. There's only going to be one axis of symmetry, there's only going to be one vertex, and there could be multiple x-intercepts. Now the last one is what we would consider our y-intercept. So if we were to come over here to our graph, this value over here would be our y. Okay, so the last thing that we're going to do is be able to graph a quadratic. So one of the things that we need to do is we're going to graph quadratics using what we call a table of values. Now with the table of values, there's only particular values that we really want to use. And so what we're going to do is we're going to try to get a good mix of positive values and negative values. So our default values that we're going to use for our table are going to be -2, -1, 0, 1, and 2. So these 5 values are kind of our default values so that we can get an idea of what's happening on the positive side of the graph and what's happening on the negative, or the positive side and the negative side of the graph. Now in some cases these values won't work because it only gives us 1/2, so we just need to adjust that as necessary. But we can always use these 5 values if we don't know where to start. So the first thing that we want to do with graphing quadratics is make what we call a t-chart. So we have kind of input, output values. So we're going to make a t-chart, And then what we're going to do with this is we're going to identify the vertex, and we're going to identify what we're going to call axis of symmetry, or what I'm going to call AOS. So we're going to identify those two things. So the first thing is I'm going to make my t-chart. So I'm just going to go ahead and make a chart. These are my values of x that I'm going to use, and this is the value of y, or the value of what we call f of x. So those two things are the same thing. Y and f of x are going to be used interchangeable. Here we have f of x equals x squared minus 2x minus 3. So I'm going to use my default values. And basically what's going to happen here is I'm going to take that function and I'm going to substitute in -2. So I'm going to take this function that I have here, that I have just kind of listed here, and I'm going to plug in the -2. So here I'll have -2 to the power of 2 minus 2x times -2 minus 3. Now notice what I did here is I used parentheses to show the negative value, because we don't want to make any mistakes on particular values that we would use, what we know is positive, what we know is negative. And then I can do that same thing with the rest of these, -1 to the second minus 2 times -1 minus 3, and I can get a value, and I'm going to keep doing that. And once I do that, I'll get values of, so when x is equal to -2, I get positive 5. When x is -1, I get 0. When it's 0, I get -3. And 1, -4, 2, 3. So I can just go ahead and I can plot these values on my coordinate plane. So -2, 5 would be here. And then -1, 0 would be right here. 0, -3 would be there. 1, -4 would be down here. And 2, 3 would be down here. Now I don't have a complete full idea here, but as one of the things, I can identify that this is probably going to be a minimum. Now if you notice, as I go from left to right, my values start to decrease, so they would start coming down this way, and then all of a sudden they're going to go back up. And so they're going to kind of look like this. Now one of the things that I can identify is I can identify the vertex, and I can identify the axis of symmetry. First of all, my minimum is also my vertex, which has an ordered pair of 1, -4. So one of my values that I use is going to end up being my minimum. And it looks like my minimum because of what I have there. Now with the axis of symmetry, the way that I define that is that x is going to be equal something. The way that we write vertical lines is x equals something. So I go right to that vertex, which is here, and I can make a vertical line that goes through the vertex. Now with this, one of the things is that x is going to equal 1 because it goes through 1 here. And so really the axis of symmetry is going to be the x value of that vertex. And so we're going to look at that and we're going to identify how that works and how that all comes together. And so as of right now, this is how we graph quadratics. We make a t-chart, we identify the vertex and identify the axis of symmetry by just going through there and graphing it and finding those particular values. And so that's going to do it for this video.